is the experiment for CHEM1210 lab, and the experiment number is 6. We're going to do the rate law determination of crystal violet. Crystal violet, obviously from the name suggests, is a violet color compound. We are going to add NaOH, sodium hydroxide, to the crystal violet, and it's going to form the crystal violet hydroxide complex. Now, this reaction is going to take some time to complete. At the beginning of the reaction is the violet color solution. When the reaction is complete, it's going to be a completely clear or colorless solution. And so our goal is to find the rate law for this reaction. If you recall from a lecture in chemistry, the rate law can be written as a rate constant times the concentration of the reactants raised to some exponent power, which we don't know, and only can be determined M and N experimentally. In this reaction, we are going to do one more modification. That is, we are going to deliberately make sodium hydroxide concentration 1,000 times higher, so our rate law now only depends on the crystal violet, okay? Because there's so higher concentration, so therefore the rate law is just on CV, okay? And so our new rate law is rate is equal to some rate constant times the concentration of CV raised to an exponent M, okay? Now M can only be determined experimentally, okay? If M is equals 0, we have a 0 order reaction. If M is equals to 1, we have a first order reaction. And if M is equals to 2, we have a second order reaction. We are going to run this experiment and collect data, and we're going to run it at wavelength equals to 565 nanometers. We're going to collect data for absorbance data for about 20 minutes. Every 45 seconds or so, we're going to collect 1 point of absorbance measurements, okay? And so at the end, we're going to just have absorbance and time data, and we are going to take this data and plot it in Excel. The first graph is absorbance versus time. If it is linear, you will get a 0 order. The next graph in Excel is Ln of absorbance versus time. If it's linear, we're going to get first order reaction. And the last graph is 1 over absorbance versus time. If that is linear, then we're going to get a second order reaction. Notice the slopes for each of the graphs. The first one, 0 order, you have a minus K, you have a minus K for the first order, and second order, it'll be a positive slope. So a negative slope is going down this way, and a positive slope will be going up that way, okay? So now we'll come to the experimental part, and we'll show you the reaction data.